teacher, and then he showed me. I think I just missed one section of it.
Multiple choice was fine.
Yeah.
Okay. Oh, question 6. That one.
Yeah.
That one. You know that's in my booklet. Yeah, you go through my induction booklet. It's exactly the same question.
Yeah, I went through the booklet and I got those questions, but then when I got to this test, I don't know, I got stuck on.
That's exactly the same. The only thing I can tell you here, I'll just do it real quick, that factorization bit. I'll show you the way I would want it done. It's 1 squared plus 2 squared plus ... plus k squared plus k plus 1 squared is equal to 1/6 of, give me a second, 1/6 of, where are we? 1/6 of k plus 1, k plus 2, 2k plus 2, 2k plus 3. Yeah? That's what we're trying to prove. So the left-hand side is this, which is your assumption, which is this with k's. So you get this out at least. You agree with that?
Yeah.
Okay. Then, can you see you've got a common factor? Oh, wait. Always look at your right-hand side. You can see there's a 6th there. So we would have taken out a 6th. So we would have written 1/6. Then we can see a k plus 1. So you would take out a k plus 1. And then really there's nothing else that's common. So then open brackets, k times 2k plus 1 plus, now we took out a 6th, but this doesn't have a 6th. So what must you multiply this one by?
6.
Yeah, and then k plus 1.
That's the part that I got stuck on, and then I realized afterwards.
That's why I'm doing it again, to just show it. Let me zoom in. That's probably a bit better now. And then, of course, this bit here is going to become k plus 2, 2k plus 3, and then you finish it off. So, all good. And then the second bit?
Yeah, the second one, I got, I think, halfway through step 3, and then I got stuck.
All right, let's do it as well. So again, 5 2k plus 1 plus 2 2k plus 1 equals 7m. You're okay with that stage? M is an integer. All right, blah, blah, blah. I.e., you're proving 5 2k plus 3 plus 2 2k plus 3. Is that right? So, yep. So then what I would have always told you is you're going to try to bring one of these two in, right? One of them. That's the logic to it. So you've got to think about how you're going to break up these so that you can bring one of these in. Well, I can break up 5 2k plus 3 as 5 2k plus 1 dot 5 squared. Do you get that? Because that's super
I ended up doing that, and then I went further down and then subbed in the 7m, but then got stuck there.
What? No, you had it. All right, then let's have a look. Equals 7m minus 2, 2k plus 1. You okay with that? I just subtracted. Equals 5. All right, blah, blah, blah. All right, next line. 25. Open bracket. 25 open bracket. 7m minus 2, 2k plus 1 plus 2, 2k plus 3. And that's probably where you could have got stuck, because these powers are not the same. So the first thing you would have to do is make those powers the same so you can simplify. So next line, 25 times 7, who cares what that is right now, minus 25.2k plus 1 plus 2k plus 1 times 2 squared. And then can you see it or not yet?
No.
Can you actually see it? 2 squared is 4. What's minus 25 plus 4?
It would be minus 20.
And then you can factorize the 7 out. Do you really see what my thinking process there was? 2k plus 1, 2k plus 3. I don't really like it, so I'm going to make them the same powers, and then it should work out, as you can see. So that could be where you probably went wrong, I would assume. That's where usually, I don't know, did you do that? Did you do 2k plus 3 and broke it up again?
No, I got stuck after I subbed in the 7M.
Usually that's what happens.
Yeah.
Students are not used to knowing that these two have to be the same, otherwise you're not going to be able to combine these two.
Mhm.
So the logic is these two have to be the same, one way or another. Even if you made them 2 to the 2k and then 2 to the 2k, it doesn't matter. Like, they have to be the same. Yeah, cool. Otherwise, all good? The rest of it?
Mhm.
Yep, done. Okay, that's fine then. Let's move on. Any other induction? That's it? Okay, that was all for induction?
Yeah.
Cool. Can I rub this out?
Mhm.
All right. Now vectors. Ugh, is there a bigger rubber or what?
Mhm.
Well, since we're here, let's do these ones and get these out of the way. How'd you go with question 8?
I knew in my head like if it like to state whether it was true or false, but I didn't know how to explain it.
Okay, so vector AB is equal to vector DE. DE, yeah. True or false?
That's false because it'd be the negative.
Yeah, negative direction. What does the absolute values mean?
Length.
Yes, that's what we were arguing about that day, wasn't it? BC is equal to vector AF. Yes, of course, because it's a
Hexagon.
regular hexagon, more than that. So a hexagon can be anything, but regular hexagon means it's all even. That's the idea. So, yeah, true. Whoops, true. Lengths are equal. Lengths are equal in a regular hexagon. Okay. BE. Let's rub. BE is 2 times CD. Okay, interesting. Well, there's no way you could conclude that other than breaking it up to something like this first.
Yeah, that's how I did it, and then kind of said that the extra parts on the side, if you would add them together,
Would be CD again.
Yeah.
Do they become that? That's the only problem. Like, you're probably right, but do they become it? Let's have a look. Let's make sure. So we've got this. We know this is X, so we know this is X. We know this is Y. We know this value here would have to be the square root of X squared. I'm just thinking, am I making it too hard? Maybe, because I should know angles. But hold on. What's this angle? 360 divided by, no, wait. What's angle sum of a hexagon? 6 sides take away 2 times by 180. Right? So what's that? 720 degrees?
Yep.
Divided by 6 is 120. Okay, so if that whole thing's 120, that means this angle in here is 60 degrees. Then you could say what this is now. That's how you would have to prove it. So if you just said, oh, therefore these bits would add up, it's not good enough.
Okay.
So you would have to actually go and say that bit there would be adjacent hypotenuse. So what's that? Cos. So cos 60 is equal to adjacent, let's call it y, on hypotenuse. Cos 60 is half, which is perfect now. See? So y equals to half x. Half x plus half x is 1x. And yes, this is true. You get it?
Yeah.
So if you didn't say that, if you just said it's a half and half without actually showing us a triangle or 60 degrees or something like that, you can't get the full mark.
Okay.
D. Rub it out.
Yep.
D. Vector AB plus vector BD. BD. Okay, vector AB plus vector BD is equal to vector AF plus FE plus ED. Vector AB plus BD is the same. It could be. You know that vector AB plus BD is vector AD because these are the same.
Yep.
You know that vector AF plus FE is the vector AE plus vector ED, and therefore vector AE plus ED is equal to vector
AD.
That's true. Happy with that?
Mm-hmm.
Okay, that's that one. Question 9. Okay. Vector AB. Where are we doing? All right, let's kind of draw this so you can actually understand. These are I, these are J's. So when it's saying like position vectors 4i, 7j, it's actually 4 here, just like complex numbers, 7 here. You know that, right?
Yep.
Yeah, all right. 4i, so that's A, and then 6, 10. That's B, and then 7 and 5. 7 and 5, sit down here. Let's just use that, stuff it. It's 5 and that's C. Okay. Find vector AB. AB. Find vector AB. How would you do it?
Would you have subtracted? So say you drew vector B from the origin. Would you have subtracted OB from it? OA?
You're 100% right. So, but the way you want to see it is just exactly like this. So vector AB, because this works all the time. So it's better to know it from the definition. So vector AB is A naught plus naught B, 0, whatever, and then 0B is 6i plus 10j, 6i plus 10j minus, because AO is in the other direction, and then OA, which is obviously minus 4i minus 7j. So happy with that?
Yeah.
2i plus 3j. Okay. This vector AC obviously becomes, again, using your same formula, C minus A, but no, that doesn't mean that. It means when you've done that, go and find the length of that.
Yep.
So equals vector AC. What do we say? What did I just say? 7i plus 5j minus 4i minus 7j. That gives you what? 3i minus 2j, and then modulus of that, or whatever. What is your teacher telling you that is?
He just says magnitude. He actually says absolute values. Like he doesn't even say length.
No, magnitude's a good one. Length is obviously magnitude, which is also good. But absolute values is horrible. Shouldn't say that. Anyways, I say maybe sometimes I just make it basic for people. But like, really not true. 9 plus 4 is anyways 13. That becomes root 13. Happy?
Yeah.
All right, next. Show that triangle ABC is right angled at A. So that's a formula. Oh, what is it? Cos angles. These basic formulas. I don't have them memorized. Do you know it off by heart?
Which one?
The find cos theta. The one with cos theta. Angles between two vectors.
Is it I think it's the dot product divided by the length of the two vectors times.
Times?
Yeah. Should be the length of A times the length of B.
Oh, yes, that's better. Yeah, that one I agree with. I think you're saying multiply the A and B and then the length. Sorry. Yeah, length of A, length of B. Yeah, perfect. So, so we're trying to find the angle between A and B, BA and CA. That should be, show that triangle is right angle to A. So hopefully that angle there gets me a right angle. So let's hope so. Here we go. Did you know to do that in your exam?
Yeah, I did that, and I ended up getting the same answers from the previous question, but I didn't get 90 degrees.
Okay, well, let's see. Cos theta, A dot B. So what's that going to be? Between B and C. So B and C. Dot product. So 6 times 7. 6 times 7 is 42, plus 10 times 5 is 50, over 6 squared plus 10 squared, 6 squared plus 10 squared, root that is root 136. Root 136 times root 7 squared plus 5 squared, root 74. Doesn't look nice, does it?
Nope.
Maybe my logic for it was wrong. Let's have a look. Root 136 times 74. And then shift cos. Yeah, no. Let me see if I've got that. All right, where are we? Cos. Yeah, scalar product in terms of angles between two vectors. So yeah, cos theta is equal to vector u dot product with vector v over given, find an angle between the vectors to the nearest degree. Strange, isn't it? It's exactly what we just did. Did I do anything wrong? U dot v, x1, x2 plus y1, y2. Divide 5 times 13 is 65, 33. No, looks pretty much what I would have done. 4 times 12 plus 3 times negative 5 is 33. 33 on 65. Strange, strange stuff. Yeah. No, that's right. Root 25. And then for parallel and perpendicular, we understood that. Yeah. Okay. And that's projections. Let me look at that one more time. In your exam, isn't it? Let's show that triangle ABC. ABC is right angled at A. Right angled at A. For it to be right angled, that means the angle between vectors B and C, the angle between vector B and vector C, vector B, vector C. Yeah, that's why. You're doing vector from here and the angle from here, aren't you? All right. You know what's wrong with that? You're doing the angle, when you're finding theta, you're finding this angle. Do you get that?
Yeah.
That's the actual angle you're finding. So that's not right. This is what you got to do. But you're going to just be like, oh, that's simple. AC is root 13. Vector AB was 2i plus 3j. Is that what we've written? So therefore, the magnitude of AB is what? 2 squared plus 3 squared. The magnitude of AB is root 13. And then what's the magnitude of BC? Magnitude of BC would be the square root of 7 take away 6, so 1 squared, plus 5 take away 10, which is minus 5 squared, which is 25. Hopefully we haven't done anything wrong. I've got root 26, and then root 13 squared plus root 13 squared. Wait, what? Am I losing my mind here? Root 13 squared plus root 13. Yeah, correct. You with me so far up to this stage?
Yep.
Okay, and then of course, for it to be a right angle, what needs to happen? Root 13, root 13, root 26. So root 13 squared plus root 13 squared must give you to root 26. Does it? And it does. So Pythagoras' theorem holds.
Would cosine rule, would that have given you the answer as well?
Cosine rule. Oh, once you've got all three sides.
Yeah.
Yeah, of course. So you could have got a right angle that way. Yeah. Well, that's usually the way we would do it. I mean, once you know you've got your three sides, if Pythagoras' theorem holds true, I mean, if you've got three sides of a triangle and Pythagoras' theorem holds true, then it has to be a right angled triangle. So, yeah, okay, use the scalar product to find angle ABC. State your answer to one decimal place. Find angle ABC. Use a scalar product to find angle ABC. All right, now I've lost it. So tell me, cos theta. Use your scalar products. What do I do in C again? Use your scalar products. No? Do you know, Ezra?
No.
Scalar products. Let me have a look at it again. Find the scalar product of this and this. So that's what we're trying to do, right? That's what you're trying to tell me. Why are you confusing it? So the scalar product, okay, that's fine. To find angle ABC. So to find that angle, it is literally what I just said. So cos theta is equal to angle vector AB. Sorry. Vector AB dot vector BC vector AB BC on magnitude of vector AB on magnitude of vector BC. Okay, let's do it. Yeah, you're okay with that?
Yeah.
Here we go. So, and then what angle you would find is this. No, hold on. You're still going to find. Did he give you the answer to this one?
No.
How'd you find that theta? Give me a sec there. Well, then I'd rather just use that and be safe. But it should work out the same. So if we are right, we should be able to use the cosine rule and get it out as well. So let's make sure. Let's do it this way, and if it should work out to the cosine rule formula, right? So let's go with this one here, which would give me what? Vector AB. Vector AB was 2i plus 3j. Dot product with no, that's wrong. That's wrong. It should be cos theta of that's right. AB, BC, and then A minus C. Give me a sec. Okay, cosine rule. Let's do that for a second. So cosine rule is equal to vector AC, which is what? 13 squared, so root 13, so just 13 plus, no, sorry, definitely not that one. It's AB squared, which is, what did we say AB was? 13?
Yeah.
Actually, I already have my triangle here, and I know it's a right angled, but it's saying use a scalar products. Okay, well, that's fine. Let me just make sure. So that angle there, this was A, this was B, this was C. So cos theta needs to be adjacent over hypotenuse. So it's meant to be root 13 on root 26. So therefore the answer has to be root 13 on root 26, shift cos, okay, to one decimal place now. 45 degrees. It's okay. 0.78 radians, 0.785 radians, 85 radians. Okay. Or to one decimal place will be 0.8 radians, whatever. Okay. Let me now look at something else. So using the scalar product. Okay, you're okay with that? What I just did there, basic, just right angle triangles.
Yep.
Which is fine, should work. I just want to see how your scalar products are going to work here. Find the angle ABC. To find angle ABC, angle between vector B should be the angle of A, C on vector A on vector C. A dot C, A and C. These are position vectors. It doesn't work like that, does it, Sammy? Because when you're doing A and C, you're finding A minus C. Let's see. Should actually work out because A minus C, C minus A is still root 13. Scalar product, what did I say? C, 4 times 7, 28, plus 7 times 5, 35, on vector magnitude of A, which is root, what, 4 squared plus 7 squared, times by square root of 7 squared plus 5 squared. 4 squared plus 7 squared, 65, 7 squared plus 5 squared, 74, root 65 times 74, and then 28 plus 35 divided by answer, and then yeah, it won't work. Now I get 24. Alright, maybe I should just prove it. Let's prove it. Prove it. Here we go. Okay. Cos theta equals scalar product in terms of the angle between the vectors. U dot B equals UV. Yeah, so let me prove it. Cos theta equals subtract. You're left with minus 2 cancels. Vector U, vector V, and the resultant. I'm going to find this angle here. So I want to find vector BA. And then I want to find vector BC. Over magnitude of BA, magnitude of BC. Okay, let's try that, which is what I'd written at the beginning. Vector of BA. Okay, what's vector BA now? BA would be negative of this, correct?
Yep.
So BA would be negative 2 and 3. I'm just going to write it like this so it's a bit quicker for us. Vector BC. Vector BC. Did we work out vector BC? That doesn't look like it. We only worked out the magnitude. Vector BC. BC would be 7 take away 6 is 1.
Wasn't it the root 26?
Yep, yeah, that's the length. Yep. So then scalar dot product of this over vector BA. Vector BA is root 2 squared plus 3 squared, 2 squared plus 3 squared, root 13 times vector BC. Vector BC is root 26. This just has to work. Minus 2 times 1 plus 3 times negative 5 is negative 17. It's not going to work, is it? I can just see it. Gets me exactly what I just had before. All right, let me come back to that one again. I don't disagree with this. BA, BC, BA, BC, and then you can have CA. Vector BA is a negative of vector AB. This is negative 2. Oh, negative 3. And let's see if that changes it up. Negative 2 times 1 plus 15 is 13. Is 13 on root 13 times root 26. 13 on this. Oh, I did it. I've just been doing mistakes after mistakes. Oh my god. I got it out. Over, technically, this would become root 13 times root 26, which equals to 45 degrees. God damn it, eventually. And then you get pi on 4, and then eventually you get 0.8 radians. Okay, valuable lesson learned. Look, your vector of your theta angle needs to be moving away. You're moving away, moving away, moving away. Do you understand?
Yeah.
So this one here needs to be moving away. Needs to be moving away. So I was using AB. It's got to be BA. Got to be BC, and then it just should work out. If you don't make silly mistakes like I just did. Have a look at it. Take your time. Don't say yes unless you really get it. So it wasn't the wrong formula. It was just I was using it very wrongly. Now we fixed it up.
So we always have to give the answer in radians? Like
Yeah.
0 point.
Yeah, because it says state your answer to 1 decimal place. That's the only reason. You're not going to write 45.0 degrees. So I think they want it in radians. So 0.8 radians. And then the projection, that formula should just be V, so it should be U dot V over U squared plus length squared and then U. So projection vector V onto U. Yep. So was that one okay, or you want to do that one D as well?
I think D's alright.
As long as you follow the formula onto U, so onto B, which means B is going to be on the outside. So you have your, and then that's it really. Okay. All good?
Yeah.
Okay, we got through that one. Now, I really looked into this again. Definitely not even in the extension 2 syllabus. But
okay. Yep.
So, I mean, I know he put it in there, obviously, but it doesn't matter. A small fishing boat can travel at 10 kilometers an hour in still water. It is being steered due west, however, there is a current running south at 3 kilometers an hour and breeze blowing. Find the resultant velocity of the boat given the speed correct for 2,000 in relation to nearest degree. Okay. Let's see what you're talking about. A small fishing boat can travel at 10 kilometers an hour in still water. It is being steered due west. However, there is a current running south at 3 kilometers an hour and breeze blowing the boat southeast at 6 kilometers an hour. So you're traveling this way. No, you're traveling west. There is something that is taking you down 3 kilometers an hour. And then there is something else that's also acting on you that is dragging you down further at 6 kilometers an hour, southeast. So technically you know the angle of that, which is 45 degrees. True?
Yeah.
Find the resultant velocity of the boat. The boat is also traveling this way 10 kilometers an hour. Do you agree with everything?
Yeah.
I'm going to put it all together now. And let's see. Okay, here we go. So, is that kind of what you drew, or you just had no idea?
No, I drew something, but it was further down, like in the
Uh,
third quadrant.
I don't think it matters where. It doesn't really matter where, to be honest with you. It shouldn't matter. All right, as long as you, yeah, it shouldn't matter. Let's see. So that is going at 10 kilometers per hour. Then you're going down 6 kilometers an hour. And then something else is acting on you. Nope, other way around. 3 kilometers an hour, southeast, 6 kilometers an hour. Yes, and then that becomes 135 degrees. And then your resultant is this. Any questions up to this stage?
No.
Now, to find this, this is that. That's easy. I just need this value here. How do I find that value? Find that value. How do I find that value? There again. And how do I find? Oh, of course, that's that value. Okay, cool. Here we go. Ready? Here we go. This is 3. This one here. This is 6 kilometers an hour. This is 45 degrees. This is adjacent hypotenuse. So this is what? Let's call it A. What is A equal to? Cos 45 equals adjacent over hypotenuse. So A over 6. So therefore A equals to 6 cos 45. Any questions?
No.
That becomes 4.24, something like that. So then what's this whole length now? Because the trick is actually to find this one here, like to find this triangle. So this whole length is 7.24 kilometers per hour south. Do you get that?
Sort of.
See, because
You
if
just
something,
add it?
Sorry?
You just add them.
Yeah, I added 3 plus 4, because technically if you're going 6 kilometers this way, then that would be the same as saying you're going 4 kilometers or 4.24 kilometers this way, and then whatever kilometers this way that we will work out, and that would be 6 kilometers diagonally.
Yeah. Okay.
Does the logic of that make sense?
Mm-hmm.
Yeah. So I can say the same thing is instead of breaking it up this way, like red and red, south and southeast, I can just say, well, that's the same as me going purple, 7.24 kilometers, or pink, 7.24 kilometers south. Do you agree?
Yeah.
Cool. The next bit is this direction here. Okay, which is what? Opposite over, you get it, over hypotenuse. So sine 45 is equal to, let's call it B over 6. So therefore B should also be 4.24, but going to the right. Do you get that one?
Yeah.
So therefore, your resultant would be 10 going to the left, minus 4.24 to the right, because you're getting pushed back a little bit. So then that would be 10 minus 4.24, 5.76 kilometers to the left. So every time you're moving 10 kilometers to the left, you're actually only moving 5.76 kilometers to the left.
Yeah.
That whole thing makes sense?
Yeah.
And then find the resultant velocity now. Of course, you're going to use Pythagoras. You're going to find how far you're moving that way. So, what are we moving? I think you get what I'm about to do. 7.24 squared plus 5.76 squared, root answer. You're actually only moving 9.25 kilometers per hour. Yes?
Yep.
And then in the direction to the nearest degree. Your direction that you're moving is head to tail, head to tail, head to tail. So that's going to be tail, tail, head, head. So that's going to be this way. That's how your resultants work. So you add your vectors head to tails, but your resultants are tails, tails, heads, heads. Do you remember that?
Yep.
Cool. And then your direction, miss, is what? Well, you know that's 45.
Yep.
You know that bit there is 45.
Yep.
You know, what else do we know? We know that's 45. That doesn't help. Should I just work it out? I was trying to avoid it, but it looks like I can't avoid it. So what the heck can I do? I can't do nothing about it. Oh well, all right, here we go. We've got to find theta. So theta is tan theta opposite over adjacent. 7.24 over 5.76. So therefore theta equals inverse tan 51.5, so 51 degrees for now, non-rounded. Still okay?
Yeah.
So the way we think about these is it's traveling 9.25 kilometers in this direction at 51 degrees. So the idea is to the horizontal is moving technically, what's this, southwest, 51 degrees, which makes so much sense, doesn't it? Like
Yeah.
he's traveling west, he's getting pushed south, and he's getting pushed southeast a little bit as well. So technically he's moving forward 51 degrees southwest. That's the math behind it all. These stuff, like hard things for me, are easy. It's the easy stuff that I don't pay attention anymore, that I've forgotten. But anyways, is that all good?
Yeah.
All right, let's do the last one. Rub it out.
Yep.
All right. Again, not really in the syllabus, but whatever. What can I do? I can't really do anything about that. He asked it, he put it in his syllabus. Like in the prelim, you should, I mean, in your trial HSC and stuff, that shouldn't really come up. You know what I recommend? You know that sample 2020 paper from NESA? I recommend going through that and seeing the vector questions they've got in there. If it's in there, then fair enough, actually. Could be in. If it's not in there, then that's pretty much what they released that so that everyone knows kind of what they're expecting this year. Let's have a read of this. A light fitting of mass 3 kilograms is hung from a timber beam by two identical chains, each inclined at 55 degrees to the beam. Find the tension in each of the chains. Let me think about this. A light fitting of mass 3 kilograms. Okay, crap. I got to start at 3 o'clock, another class. Let's get this out of the way. Do I need to go through the multiple choice as well? Or is this the last?
I don't think so.
Okay. A light fitting of mass 3 kilograms is hung from a timber beam. Timber beam by two identical chains, each inclined at 55 degrees to the beam. 55 degrees to the beam. Yes?
Yeah.
And there's a light of mass 3 kilograms hung from a beam by two identical chains. Sorry. It would be the other way, wouldn't it? Because it's just one light. Like that. 55 degrees to the beam. Really bad, but I'm assuming they're trying to say that one there. That's the only way that would work.
Yeah, that's how I drew it.
Yep. 3 kilogram mass, so 3 kilograms going down. Each incline of is taking G's, find the tension in each of the chains, correct the nearest Newton. Tension. I think were you guys assuming tension is the same?
Yeah, that's what I assumed it is.
Yep. And then tension would be going up, right? Because if this thing's going down, tension's going up. Do you understand
Yep.
that? Okay. And then pretty much all your forces. Your forces are what? Your forces are T, going up, going to the left. That's 55 degrees. So therefore this one here is opposite over hypotenuse, which is opposite over hypotenuse. So that should be sine, and that should just be T sine 55. You're okay with me writing that?
Yeah.
And T cos 55, and then same thing for this one here. And then you only have 3 kilograms going down, which means your force is equal to 3 times 9.8. It's just a problem that he hasn't given the answer to this one here. I just need to know, what would he have done? Alright, what can I do? Look, the answer is either T sine 55. Tension is the same all the way through. See, usually, you know what you're meant to do? It's meant to be T1 and T2. Because it moves, you know, but basic questions, I can't remember them. A light feeding of mass 3 grams is hung from a timber beam by 2 identical chains, each angle 55 degrees to the beam. Find tension in each of the chains. I guess the tension is the same. Should I divide it by 2? All right, Ezra. Look, so T sine 55 is equal to 3 times 9.8, because what goes up must come down, or the forces that are going up must equal to the forces going down. Yes?
Yeah.
And then my answer would have to look something like this for now. You want to add anything to it?
No.
Did you do that? Did you do something differently?
I ended up doing the tension because I forgot about the 3, and I just did tension equal 9.8 times cos 55. And I think
T times cos 55, which is you're saying to the left.
or it should have been divide. I think that's where I went wrong with that one.
But not cos 55, it should have been sine 55 as well. Because if you're saying causes are going left and right.
Right. Okay.
If this thing's not moving, then there is no force to the left.
Mhm. Oh yeah, yeah.
The only force to the left is technically what we call centripetal force, so the force acting towards the center.
Mhm.
So the answer is either this, so like, I don't know, 35.89 or whatever. The answer is either this, or the answer is this plus this, so 2 of these, and then you divide it by 2.
Mhm.
It's either that or this divided by 2. That's
Yeah.
something you just got to confirm with yourself. You can say, hey, listen, like, yeah, because technically it's not moving, but
Mhm.
but the idea is you're meant to make this move into a conical pendulum so that it looks like a cone. That looks like this. It moves in a cone direction, but if you can see that in like a circular motion. So I think for your course, for what they're trying to make you do, I think it's just the T sine 55 equals 3 times 9.8.
Mhm.
Tension in either, actually I can quickly prove it. If that is 35.9, wait, T, what did I say here? 3 times 9.8 divided by sine 55. It's 35.9. Yeah, it would have to be divided by 2 actually, because each one of these, the forces are equally distributable, right? I'm going to go with divide by 2, and we'll see what happens. So talk to your teacher. See, the reason why I'm saying divide by 2 because it's going to be evenly distributed.
Yeah.
That's my logic to it. Let's see what the answers say. All right, all good now.
I think so.
It's question 10A. I think that's probably a bit more important than question 9. Now you know how to use those angles and those formulas. This one here's wrapped up. Yep. There's the angle between the 2 vectors. Cool, that's pretty much what we just did. And the diagram's vectors OP and OQ represent the force of magnitude 42 and 35. What is the magnitude of the resultant of the 2 forces? So just going to add it on top. So that's 30 degrees there. So then when you add Q, that's 30 degrees. And this thing is 60 degrees. So just be aware of that. So, actually, you wouldn't need the 60 degrees, would you? So you're just going to do, what are you going to do? How did you do this one? Am I overthinking this? What is the magnitude and direction of the resultant of the 2 forces? OP, and OQ. What is the magnitude of the 2 forces OP and OQ? Yeah. So you would have just added that 30. What did you do for this one? 30
I
degrees.
ended up joining, so at P, and I just did a vector down to Q.
Say that again. Say it again.
At P, at point P, I ended up drawing a vector straight down to Q.
Like that. Yeah.
Yeah.
And then?
Yeah, that's how far I got with this one.
No. So the idea is you want to find vector PQ, which is right, like what you're doing. But the
Yeah.
way it is, this is 30 degrees and this whole thing is 60 degrees. So that's going to look like that. That's going to be your Q using your parallelogram logic.
Oh, yeah.
That's 30 degrees. And then you're trying to find that one. That's the one you're trying to find, OQ.
Okay.
Which is magnitude of that and that. So OP plus PQ. Yeah, that's right. Okay, so how do we do that? How do we do that? Let me see. How do we do that? How do we do that? It should not be hard. So why am I stalling? That's 30 degrees. That's 30 degrees. It's 30 degrees. Why can't I put it all together? That's 30 degrees. What's this angle? Oh, there we go. Okay, that's 60, right? Look. Not 60, that's 120. Co-interior angles. Do you understand that?
Yep.
120. So then this whole thing is 150. When that's 150, then you would use 42, 35, and hopefully x squared equals 42 squared plus 35 squared minus 2 times 42 times 35 times cos 150. Let's see if we get an answer that's there. Square root answer, 74.4. And then you're just trying to find this angle. Best way is to probably go find theta in here, sine rule or something, and then just do 60 minus that.
Yep.
You get what I mean?
Yep.
All right. It's okay. All right. I gotta leave it there.
Thank you.
If you need some more help tomorrow, just let me know.
Yep.
Tomorrow you're probably looking at around 8 o'clock at night or 7 o'clock at night or something like that. So let me know.
Okay.
I'll help you out. Do you want me to save
Thank
this and
you.
send it to you?
Yes, please.
There you go. Let me send it.